This is TempleOS 5-Minute Random Code Walkthrough episode 79, and I'm your host, Terry Davis. Okay, looks like we're in the kernel, and we are in servant command. This file is for when one the best if you press F1, go down to tasks. I was really confused until I made this diagram myself. So each core has an executive, I guess. I don't know what you want to call it. Adam is on core 0, and on the other cores there's Seth. In the Bible, Adam is the first human, and Seth is his child. Anyway, so the term, technically Seth is Adam is the Seth task on core 0. So it's kind of a string. Anyway, so at boot, Adam gets everything compiled and gets everything running. Adam wakes up the other cores and they start running. And when Adam starts up, he goes into this loop of executing server commands. You can hand him a command and he will execute it. He waits for commands, and you can't tell him, you can't type commands. They have to come from somebody else. So Seth, you give him commands and he runs them too. I'm not sure why we have these others. Basically, you run commands. So now other tasks, a user task executes the command line. You can give him standard in, you can give him text. I don't think he responds all the time. If he's busy doing something, he will not do a command, and he only does it if he gets around to it. So I don't think you can give him commands. Commands have there's 5 types of server commands. You can give text input that feeds into the standard in. You can give him a message, that's for the message loop. You can give him a string to execute, and he will compile and execute it. It's kind of similar to, well, anyway, you can tell him to call a function, or you can tell him to spawn a task. And server command nodes are one of 5 types. User applications deal with text or messages. Serve command run will do a function task, spawn a task, or execute some code. So user applications do the text or message. These servers do execute a string. Okay, so let's go back to where. So we just landed in crosstalk with wait. So if you're curious, I guess we can go ahead and Alt-V for, okay, now Control-Alt-T for tab. Now I'm over on this window. I'm going to escape out of here. And up at the top is my process ID. That's my, if I type FS segment register is the current task record. It's the FS segment register. You'll see that's 828, 828, E28, E28. So if I say crosstalk, and then I say, let's go, I'm going to cut and paste this hex number 0x, comma, Now this takes a printf format, so technically we can do a very nice full-featured. We can do variables if we put them on the command line. Let's just say dir. Oh well. It'll take a printf, so you can put arguments. What happened? We had. Let's walk through what happened. Code walkthrough. That was what I was doing. I printed the fs missing semicolon at s. And I don't know. Let's try it again. Oh, I did a \n. That's okay. I think I had the cursor in the wrong. I left the cursor in the wrong spot. Like if you leave the cursor here, now when I do it, it will. Yeah. Okay. So if the cursor's not in the right spot, it will do that. So crosstalk with wait. Watch this. Let's do. I'm going to sleep for 10 seconds. Now, if I tell him to do this, we're immediately back. And now, if I tell him to do something else, he's not done. Now he's done. Now, let's tell him to do that again. Oh, I better be careful about the cursor. You programmers will understand. Oh, this is not going to work because the sleep is considered idle. Okay, this waits for him not to be idle. So if he's sleeping is idle. For I equals 0, I less than 0x 1 2 3 4 1 2 3 4 semicolon I plus plus. Okay, so there's a busy. So task. Okay, now let's just do this. So he's busy, and now when we tell him to do this, it waits until he's done. And then it comes back. So that will wait until he's idle, but it's tricky because he can set his idle flag all over the place in different commands. So you have to be careful. So this, God told me to explain crosstalk with wait. Now this is one of the there's a huge number of routines in the printf family. All these routines have format and arguments, and the reason is because it's really easy and nice doing ... functions. I don't know what they're called, variadatic. Let's just call them ... dots. Anyway, so when you do a ... in TempleOS, you know how in C++ you have a this variable? Where does the this variable come from in C++? It's an invisible variable, isn't it? Well, in Holy C, you have two system variables, argc and argv, and they should be immediately obvious what they are. So I went ahead and made my my print join. That's basically what they funnel into. It takes argv and argc. So this, if you tell it null, it mallocs a huge, as big a buffer as necessary to hold the printf string. So this will hold any size. This, if you do null, This returns an allocated string. We don't worry about buffer overflows. We just crash. So seriously, people think that's funny, but we want simple code. And you know, if somebody wants, it's like a motorcycle. If you tip over on a motorcycle, it crashes. Don't do that. That's just what you don't do. And it's really ugly to have to put an overflow check every single time you use a buffer. So we don't have any overflow checks. And if you have a limit, that just sucks, because you always hit the limit, don't you? Whenever you have an overflow, you have to, yeah. Sometimes the limits are ridiculously low, but we just crash. It's your machine 100%, so if you want to use up all the memory, that's your option. This is not a server with other users. It's your computer. Anyway, so this allocates a string, and then what do? We get a little bit fancy here. We do now we call this is memory string allocate. It's the same thing. What do? We tell it to we put it in quotes, so it's going to print it. This gets tricky, doesn't it? What the hell is this? Then we print it, and then we free. Okay. So we're getting tricky here. This string is on our heap. This string is on our heap, and we want to free it in case. Now, if we die, that leaves it stranded. And the other task, well, that's an example of don't do that. Anyway, don't die. Don't die. Actually, as a matter of fact, it's not quite, we're not giving it this string, we're giving it this string, as a matter of fact, but it's the same difference. We could allocate off of his heap. You know, maybe I should do that. It gets a little tricky. We can allocate off of his heap, but I don't care. We could do that. All tasks are on the same address map. So that's, yeah, I guess I kind of screwed up, didn't I? It should be on his heap. But it gets ugly because then I have to deal with the length. Anyway, so what are we doing? We're sending text. Oh, I know what it is. Okay, so the when you send text, how do I put this? It's an auto file, and what an auto file is a it's a pipe. It's piped through a task, and so the output goes to standard. The output of the auto file goes to standard in, and the input of the auto file comes from the source. Anyway, basically this is a pipe task. It's an auto file. So we can review this elsewhere. Long story short, we put it in his buffer, and then we free when we have printed it. So we don't stick around very long. We could die, it's true, but when he processes it, he makes a copy of the whole thing. If it's big, he makes a big copy. That's just life. And then we free our, and then we wait for him to be idle. This is a really simple operation here. Tasks have an idle bit. As long as he hasn't been killed, he's still valid, and he's not idle. Oh, we also check if he has a command in his buffer, so it's a little bit safer. So if he's got commands in his queue, or he's not idle, it's kind of voluntary when you mark yourself as idle. Anyway, and it happens periodically. When you print something to the command line, it might idle for a second. You have to be careful. I don't remember. but it yields the CPU. I don't. Maybe it doesn't go idle. It just yields the CPU. Anyway, so we can talk about auto files. So these are auto strings. Auto is just raw text that's been the auto string. This is what I'm talking about. This is a an auto file is a mini program. Here's what an auto file is. An auto file is a mini program that standard out goes to standard in. So if we do this, if we say auto, let's move this. I'm going to move this to AUT, and then I'm going to do a directory. Now I go auto file, and he did that directory. Now if he gets an input, he does not pass that on to the this is like a pipe, and he's in front of the slave. So it's going to wait for this master to, so now we're going to do this auto file. It's going to wait for me to press a key, and then it's going to do the second one. Does a directory. Now we're waiting. Now I'm going to press a visible character. Oh, it did it. That's too bad. That's not what I was expecting. It echoed it. Well, I guess that's yeah, that's what it should do. The other answer. Okay, so we say comma false. It's not a problem. I was just disappointed. Oh well. It's the right answer, don't worry. All's well. Now I hit T. It doesn't echo it, and it does the directory. Okay.